Okay. So let's put that. Okay. Hey, Harry. Welcome back, man. How you doing? Nice to read you again. See, okay. I just trying to arrange something in here, you know. Um, I I'm doing well. I'm doing well. It was a very tired week, to be honest. And I just wanted to reach this moment and try to relax myself and do coding, you know. Today I'm C++, by the way. I am not in Python. Because I finally can compose my data from tile and using Python and then writing the file. So finally, Harry, after a lot of time, I am able to reach this moment when I try to render the map. And you just you are just saying what are my maps right now. You can see in my, I don't know nothing about C++. Yeah, I mean it's not that different than uh, coding logically in Python. So I mean it's not that different. But anyway, you will see that I have here some looping, and I am looping through the data I create from Python, and I'm just looping through bytes, to be honest, right? And yeah, but I am looping badly because as you can see in my in my render in my game, the map is looking weird, right? I can show you game capture. I can show you a bigger screen. Yeah, that is not even a map, right? It's like what? Nothing. I mean, it's just glitches. Have you ever seen these games that has just glitches? What happened to the map? Nothing actually. I'm making mistakes with the render, but it's kind of easy to spot the problem. The thing is, I cannot I cannot code it yet because maybe I don't understand clearly how to manage the data. That is the whole problem. I can show you in the book. Here's the book, Harry. And the thing is, the problem is as follows. This is the map. This is the whole world. It's kind of small world, and the world is composed by rows and columns, right? Like this. So what I'm trying to do is kind of an optimization, early optimization, to be honest. But because when you code, you must try not to do early optimization because that is hell. Yeah, I'm kind of doing the wrong things here, but I just know how it works, so I would like to have the optimal way to do it early in early stages. Okay, Harry, that is for sure. That's for sure. So what I want to do is to render just the part where the player is the part of the world the player is, just this part. So this is efficient because you ignore all this data, Harry. All this data you ignore, so you don't process and you don't send to the GPU. You don't do anything, right? Because it's not worth it to process because the player never see it, right? So I just want to spot this part, and you are seeing that spot in the game, but this is the wrong way. So what happens? Probably my algorithm is not working well with the offsets, because of course the data is sequentially in memory. All this data is sequentially. So just try to imagine that this is the first row, but after the first row you have the second row, and the second row is this one, but sequentially, like this, like a whole buffer of data, bigger buffer. But I know I need just to split just after this byte, this tile, just after this, because I know how width is the word totally, right? Here. Actually, this is like 100, 120, just right here. So I know that after 120, I split the row and I put the row here. And then do the same for the next one and do the same for the next one. And as you can see, I am composing the columns using the rows. So when I reach this point in this coordinate, I just need to take this actual tile, this one, Harry. It's kind of easy to see this one. God damn it, this one. And I can. I can. So then after taking this, I must take this one until here, ignore this one, and then move to the next row, and then ignore this one, and take this one, take, ignore this one, and move, and so on and so on and so on. So that is the whole magic, Harry. I mean, it's kind of easy to explain, but I cannot code it. Gosh, I kind of, what? Yeah, I'm trying to split the data because, Harry, listen, the data and the memory and the computer is always sequential. It's always sequential, but of course, in any application, in the whole computer, the sequentially is not always preserved. For instance, in the memory RAM, that's why they call it random access memory, RAM, right? So in the random access memory, the computer just take portion of that memory and save data, but randomly, random access memory, just randomly. It's not sequential for all the programs. So maybe the program A save data at the beginning of the run, and then a program B save data just after the data of the program A. What that means? That means that if the program A wants to save data or more data, it's going to save data after the program B. So as you can see, the program A is already the data of the program A is already split all over the place of the run. Okay, so it's not always sequential. That's why it exists a concept that's called pointers. But that is not my problem, Harry. That is not my problem, because I actually have the data sequentially, and I know it. I know it because I save it like that. I know it. I know, Harry. Ah, damn. So probably I mess up with the arithmetic of the processing of the rows and the columns. That is my whole problem. And as you can see in my game, that is not how the games look like. The game looks like this, of course, like this one. You can see the differences. All right. Oh, sorry, you cannot see it because I need to move. There we go. See, this is different, right? It's this is the actual tile I need to render, the whole row. And if you count all these columns until here, you will count 120. And then this one will be 121, 122, 123, and then you move it, and then you start like just splitting. It's kind of easy to see. But yeah, I mean, that is also a way for me to tell you that the coding is not like fast lightning, you know. Those guys you see coding like lightning, it's just for the video. Just for the video. It's a true that when you code you are slow, at least when you are facing a problem that is not easy to solve. Anyway, I am trying to make a new algorithm, trying to revisit my algorithm to spot the problem. That is my whole concern today. And in C++, what you have in C++ to help you? Okay, this is kind of a problem of mapping function. It's called it in computer science. It's like you are having discrete data in a whole of continuous data, right? So this is easy. This is easy to see. I want to explain you right now. Here, with this variable, I just take this variable to explain the purpose of this. When you have coordinates, of course, you can have coordinates like 10.1, 10.2, or 0.5, 0.10, something like that, right? But you have to map that data in a discrete world. In this case, when you do pixel art or pixel art games like mine, you have discrete data. You have a discrete world because my tiles are 16 by 16. So when I have a coordinate like 1.0, I just need to divide 1.0 by 16. So and I will have the integer part of that division, and that will be my discrete function. So that's why I have here this product where I take the y coordinate, y label of the coordinate, sorry, and then multiply by 0.0625. This is just this one, like this. This is this. And you are probably now, Harry, asking why you just do this like this instead of multiplying. Well, I will say that I will keep multiplying because it's kind of more efficient than doing division. Although, of course, doing this is not that efficient at this. I mean, I am not like saving a lot of processing here. It's not the point. But I just want to take this just because. Yeah, just because. Okay. So, yeah, with this, I'm computing the initial row. And the initial row is the part, the row where I'm going to begin to take my first tile. Okay, the row. And in this example I have here exactly, I'm doing this. See this, Harry? You will see this. It's kind of a way for me to have the best case scenario. Here, look. See my camera. This is my camera object. My camera object is hard-coded in the position 0, 0. And this is my width and this is my height. This is a way for me to test the algorithm, Harry. Why? Because when you do an algorithm, is the best way to approach the general case is by making one case, and then you can generalize. So this is the case when you have the camera at the origin of the space, right? So I am not using any other position, because by using other position or by dynamically computing other position, I adding complexity to my test, and I don't want that. Okay, so it's hard-coded. When the program reached this instruction here, I'm taking this 0 and multiplying by this. I know for sure this will be 0. I mean, this will be the first row in my map. So this is in my notes. This is initial row. Actually, I'm going to change the name because this name is kind of big. Initial row. And this is telling me I'm going to change this, and this. Why is not going to change this? What is this? Oh, what a mess. Okay, I'm going to discard this, Harry, because I have a mess here. Even though, okay, anyway. Let's try to fix it, Harry. Help me to fix it, Harry. Help me here. Okay, computing the initial row. So have you found the solution yet? I don't know. I didn't. But I'm close. I feel it, Harry. I'm close. First, let's focus on this. This is the first row, the initial row. Okay. Now I need to multiply this. I had a few little activities in Python to fix bugs, but extremely basic. Let me know, Harry. Maybe those things I don't know. Trust me, I learn every day new things. Maybe you know something I don't know. Tell me, what are those extremely basic things you have done? Please tell me. Maybe you can help me. Okay, I will say this is okay. This is okay as well. Okay, these 3 lines I will say are okay. After this, I'm going to move the initial column computation because I would like to connect the calculation of the first byte of the spot of the square of rendering. I want to close. I want to all those instructions to be close to each other. That's what I want. Okay. Then I know that this is going to be the first byte. Remember, Harry, we are moving through bytes. We are moving through bytes, Harry. And a byte is just one portion of a number of 4 bytes. That's why we are multiplying by this size of data. You probably have heard this, Harry. You have data types in programming languages like Python. You have data types, and those data types are just bytes, Harry, just bytes. But the difference is how many bytes are those data types. This is an example. You have, I will show you, Harry. I will show you this here in the comments. If you have one single byte, Harry, one single byte, you will have numbers in hexadecimal. I hope you have seen hexadecimal. You have from 0 to 15. From 0 to 15. In hexadecimals, that means you have 0 to 0f. Right? This is 15. Okay? This is 1 byte. You have 1 byte of information. And to know how many numbers you can have, I mean decimal numbers, how many numbers you can have using one single byte, you must do combinations of those of numbers, of hexadecimal numbers, in using those 2 bytes. For instance, I can have 0, 0, 0, 1, 0, 2, 0, 3, right? Until reach 0f. This will be 15. Then, after this, I have 1f, 2f, 3f, 4f, until I reach, no, sorry, I have 1, 0, 1, 1, 1, 2, 1, 3, until I reach 1f. Okay, so continue. We have 2, 0, 2, 1, 2, 2, 2, 3, until I reach 2f. And I will continue doing this, Harry, until I reach all numbers to ff. And when this point is reached, I won't have more numbers using just a single byte, Harry. What that means? That you can have 256 possible combination of numbers using just one single byte, Harry. So if you have, for instance, or if you want to process 257, the number, you can use a single byte. You can use it here. So in that moment, when you reach that moment, you need what? What do you think, Harry? What do you need to think you need? when you have this number? How many bytes, Harry? Yeah, 260, 256 is equivalent, let's say, not equal. It's equivalent to have 1 byte to store data, to store data. But after that, 257, you already have more numbers to store than in a single byte. So that means you will need 2 bytes, Harry. 2 bytes. And what is that? You will need a number with this specification, 0000. This is 1 byte and this is another byte. And how is that? Well, with that, you need to again do the whole computation. You have 00, 0001, 0002 until you reach 000 F. And you will start doing the combination again. 0001 F 000, oh sorry, 0 001 1 0 and so on and so on and so on until you reach 226 256 combination, Harry. So for here you will have all these numbers to store. Just all these numbers to store. And 2 bytes, Harry. But again, if you want to process a bigger number like 1 million, that is not enough now. You have to again have another byte, Harry. And again, you need to do it. In according to the number of bytes you have, you will do the multiplication. If you have 3 bytes, you will have this amount of numbers, and with 4 bytes you will have this amount of numbers. It's a lot of storage. It's big numbers. And in my case, Harry, I have numbers like this one, like this. And you now, Harry, can tell me, you have the proper knowledge to tell me, ooh, Alter, why do you need that amount of storage? It's a lot just for a single number. Really? Each tile you have in your game, each tile, each square, you need that amount of storage. It's a lot. Are you sure you're doing the things well? You can tell me, Harry. Now you have the knowledge though. And I can tell you, well, Harry, by now I just trying to have these numbers like this because tile this program give me the numbers in that format in 4 bytes. Yeah, I know it's a lot of information because I don't have that amount of tiles because these numbers is huge. This capacity is huge. It's a mongoose, right? But I don't want to deal with the data the tile give me, Harry, to be honest. I kind of lazy right now doing that because I just want to progress. I just want to do the things work like the render. And then moving forward, doing iteration to improve some aspects. Because maybe I just need 2 bytes. Harry, I just need 2 bytes because I don't have a lot of tiles in my world. But I can do something else. Maybe I can keep this amount of data because in the first 2 bytes I can store different data. That depends. That is called decode, Harry. Decoding the data. What is that? As I told you, with these 2 bytes you can store this amount of data, this amount of numbers. Just imagine to have 65,000 possible numbers in a game for rendered tiles. Just imagine to have that. It's a lot. It's a big map. But I can keep having this because having just 1 byte is too little. I easily can have a 256 data, Harry. I can easily have it. So I can keep having two and use the other two to store different data, Harry. And I decoding data using 4 bytes. I'm decoding data that exists, Harry. That is actually how the compression algorithms are done. You integrate data into the data that appears something else, and not even the compression algorithm, Harry. You can also have virus in that way. Yeah, virus. Viruses are storing in data like you don't even know they are there because the program just codify, just use it. So just imagine that one hacker said, okay, this program is using this game, my game. maybe you please, Harry, don't think that I'm coding a virus here because you will spread the news. This guy is coding a virus in the game. Don't buy it. Don't use it. Don't play it. Okay? I'm just telling things. Oh, give me a moment. I will ban this bot. Okay. Okay. Listen, Harry. It's something is realizing. So somebody is realizing. Oh, this program use just 2 bytes out of the 4 bytes it's processed. I can put data there because I know the program is never going to use that data. So I can put data like hidden data, right? Hidden data, and then when this program reach this part, I can move this data here, and now it's different data. And when the program is start writing this, because it's a music program, now I can infest this. It's kind of like that, Harry, when you have something hidden in the code. It's something like that. You hit something that is also there is also a kind of way to hit data, to occlude data. I don't remember the technical word, but it's kind of amazing, Harry. It's like taking an image and use some bytes of those image to store information. I mean, like text. How is the name of this technique? I don't remember, Harry. I will tell you. I will look forward. I will do the research and I will tell you the next time. But this is the technique that where you have an image, any image, Harry, any image, and you probably know that image are normally image decode data in 24 bits. 24 bits. 24 bits, Harry. 24 bits are the equivalent of 3 bytes. Okay? So what happened with the last byte? Or maybe you just the first 2 bytes to store the colors, and you save 1 byte to occlude your information. And I can pass you one image, Harry. Take this image, Harry, and we both know that that image contains occlude data. And with another program, you can take that data out of the image, and now you have my message hidden in that. What about that? What about that, Harry? Anyway, that's why I have this, Harry. Because I know any number or any tile in my stream, in my map is made by 4 bytes, and these functions give me that 4 bytes. So I will erase this, and I will keep this. So that's why this variable is called initial string byte, because after computing the row I have, after computing the row, I need to render, Harry, the row. Okay, the column is a different history. I then multiply these by 4. This is 4, Harry. If I have here 32, that means are 32 bits. 32 bits divided by 8, because each byte has 8 bits. This will give me 4. Okay, that's why I know this is 4. If I have, for instance, A here, I know it's a single byte because it's just 8 bits. If I have here 16, I know how many? 2 bytes. Because here, this will give me 2, right? And that is the data type, Harry. Python also have it, but the thing is that the Python has another layer that abstract you for this, and you don't need necessarily to specify the amount of bits one byte has. And that is actually the theory behind the data type, at least the primitive data type. And also, of course, you have 64, which is very, very big. But anyway, I know that my data is in 32. Okay, this is the first byte of the selected row, Harry. This one, I'm going to explain this probably later, Harry, because it is more complex. I will explain you with a better diagram. Now, I actually can explain it to you right now. Harry, you are helping me a lot with this, trust me, because I am checking my algorithm by doing this whole explanation. Here, I will do it here. The way I store the data, I think I already explained this to you. I don't remember, Harry. If not, just tell me you actually explained this. Alter, please continue. There we go. Well, when you render this, Harry, when you render the maps, you have layers, different layers. I can show you in Tile. I can show you here. See, my world has layers because I have different information in each layer. This is for me, or for any program that you can design using image to control the overlay, right? You put layers on top of other layers to make the effect that you have complex maps or complex image. That's kind of straightforward, right? So I have 1, 2, 3, 4, 5 layers. 5 layers of data. You cannot see it. Sorry. Yes, I need to remember to change this scene. Sorry, Harry. As I said, you have here 4 layers of data. All this layer has numbers, Harry. Numbers. Just the numbers I already told you. Numbers of 4 bytes. Okay? Okay. So, I can also show you, Harry. This will be helpful. This is kind of scary, but don't worry, Harry. This is just people that understand this thing start saying that this is scary. Don't look at it. Oh, you will kind of disappoint of learning things because nah, Harry. I don't like that kind of people. If you explain the things properly, you will understand that it's not like yeah, it's very complex. It's just for me because I am clever. See, actually this one, oh, this is really big. Unable to read. Oh, I know why. Anyway, I can show you this one. I think with this one would be enough. and I will close the game for you to see it. There we go. This is binary data, Harry. This is binary data. And my data start here and end here. And this is all data. And what I can actually see things here, Harry? Yes, of course. Remember, my numbers are 4 bytes of data. 4 bytes. So 1, 2, 3, and 4. This is a number, Harry. And if I want to know the value of this number, I had to do the conversion and so on and so forth. But I don't care about this because what I want is to compute the start byte where my data is going to be read at the first place. Where? Okay, let's begin with the explanation. Here in my notes, I have the same binary. Just imagine this is my binary. And when I don't have offset, or when I have offset 0, that means that I am positioning in the exactly beginning of my binary data. Okay? So when I compute an offset, I normally pre-compute where is going to be that offset. And I know that offset will be at the end of the layers I put in the binary data. So I know a layer is like 60 numbers. 60 numbers, Harry. Numbers, no bytes, numbers. So that means if I multiply 60 by 4, because my numbers are for 4 bytes, I'm going to have the beginning, like here, for instance, the beginning of what, Harry? The beginning of the next layer, because I know my data is sequential. So what that means, if you multiply the current offset by another 60, what that means, you are going to move to the next layer, because again, it's sequential. That's it. Exactly what I have here, Harry. This is the offset of the layers, because of course I need each layer to render, because I need to render all that to compose my world. That is the magic, Harry. As you can see, it's not that complex at all, right? So having this, I know that when I finish, when I start with the first layer here, this one, I'm going to first compute the initial row of that layer. Any layer has row. Okay? Any layer. That's why we have here a 4 through the layers. You can see the number here, number of layers. Each layer has rows. So taking the first layer, going forward to the corresponding row of that layer, I move here, for instance, because the first one. And then after this, I'm going to multiply. I'm going to multiply by this, because I want to convert tiles to bytes. And I know each tile corresponds to 4 bytes. This one. Okay? After that, I need to move to the column, because what happened, Harry? Well, what happened is I am at the beginning of the row, and that is okay. But I need to move to the column now. So I have a small offset here, a very small offset. But you can tell me right now, Alter, but you are at 0. That means the column has to be the column 0. because you are in 0 here. Here. That is correct, Harry. Exactly. So I expect that this initial column will be 0 because this coordinate will be 0. Okay. That makes sense. That makes sense. But something is missing. Something is missing. And what is that, Harry? We have this spot here. The initial string doesn't take into account the column yet. See? I have computed the initial string, but the row initial string. But I still have the column left. So what I need to do here, Harry, is to put initial column. See how similar will be this. See how similar. See? Multiply it by 6 of size of this one. Like this. Why, Harry? Because as we did here, when we compute this, the tile row, we multiply by this because we need to switch the data to the corresponding amount of bytes, because we store the data in bytes, not in tiles. And we know that each tile corresponds to 4 bytes. That's it. That's it. Okay, so we do the same with the column. Being here means that I need to move more bytes to the left, to the right, sorry, and take this. I think this is the correct value, Harry. We have the correct value. That is correct. That is correct. So why the data is not rendered properly? Okay, let's continue. We have the first byte, so we need to move this have the status. Okay, let's compute the position in the streaming. Let's compute the position in the streaming. This variable, Harry, will be the beginning, will be the variable to use here in this variable. I will explain to you this variable. This is kind of easy, and with your knowledge of Python, you will understand it. Put in here. I will do it here. I like to keep the previous value of the line, just if I'm going to roll back fast. As I say, Harry, we already identify the byte, the starting byte of the binary string. So that means this variable, it will be the one that select the first byte in the list. I told you, the knowledge of Python will help you here. I have here a kind of tricky line. You will see this line is como, what? It's like, what is that? But it's not hard to see it. It's just let's split. Let's take apart. Let's take this one here. This is like the most tricky. This first portion of the line, Harry, is just the name of the list. C++ is kind of like this. But this is just the name of the list. This is just a list. But I need to put it this way because I need to access by the directions using address of the computer. It's kind of just try to imagine, try to use your knowledge of Python, Harry, to understand this line and said, okay, I want to access the byte in the position I already compute. I already compute the position. So I just need to use the list and put that value in the square brackets, just like Python. mean, that's it. See? That's it. Nothing else. So here, Harry, you will have the data for the first tile. The data for the first tile to render. Excellent. The rest of the instruction, Harry, is just to copy the data. It's just an equivalent to say like this, Harry. Just an equivalent to say like this. See, it's not that complex. If you substitute this for a name, it's just like this. But of course, C++ has this complexity that you will handle that complexity soon, Harry, if you understand properly the Python course and the knowledge you receive from logic and programming logic. You will see that when you apply that knowledge to other language, it's not that hard. It takes time, of course. Don't press yourself, but you will see it. C++ is kind of like this. It needs to do that way because yeah, the data is in these formats and in the programming language is coded like that. It's another way. And yeah, it's doing like this. Cool. So now I have the first row. This is the data for the whole first row, or at least the row I'm going to render. The next, Harry, is just to iterate through this data. As you can see, this 4 here is just for iteration. Start in the position 0 of the data I take. I mean, start this position, this one, in the notebook here, this position here, and then take this number and put it in here, number. And if that number is 0, of course, I have coded the 0 to make a number like no tile. Why? I can show you. In tile, I can show you this. It's kind of easy. See, I would like to show you. Let me see if I can. I have a very nice way to show you. Highlight current layer. I think it's not this one. Anyway, I will do it like this. See here. This is foreground layer. As you can see, the foreground layer just have images here, and all this spot, Harry, all this spot where no image is in there, that means 0. So that means the 0 number doesn't have image associated, so not rendered. Okay, so that's why 0 is has to be different than 0. So if it's different than 0, you don't render the image. That's why. Okay, cool. And that's all, Harry. That's all. See, that's the algorithm. It's not working. Okay, okay, we have changed something. Now let's try it. Just let me see if we need to make another thing. Initial column and initial tile row. And I think final stream is not yet properly used. We will need this data soon, but let's try it like this, Harry. Let's see if we fix something. Let's say, Harry, come on. Come on. It's compiling, Harry. It's compiling. Okay, almost there. Okay, almost there. No! What is this? What is this? Why? Harry, it's just this, just the freestyle. What is this? Oh, God. What did we, but what happened? What happened, Harry? Oh, what is happening now? Now is worse, but we did it correctly. We did it correctly, Harry. Oh my goodness, let's check it again. Harry, now it's just taking like, okay. Let's debug. Let's do some debugging. Hard debugging. Okay. Let's put hit the breakpoint and start analyzing what is going on. We will watch the code in execution, Harry. I don't know if you have seen the debugger in action. We will do, but we will have some action right now. Okay. Yes, time to debug. Okay, when the program reach this line, what we have? What exact initial row? What exactly we have? Layer index is 0 because it's the first layer, correct? Then tile initial row is correct as well. This is correct. Streaming row. We actually use streaming row, yes. Let's see initial byte. Initial byte string, this one. Zero. I think that is correct as well, right, Harry? Because of course, if we are in the 0 coordinates, the first iteration will be 0, and the next one will be, let me think a bit, this is just arithmetic. The next iteration, the next row, because this row is going to be increased. See, Harry, this multiplication, this is kind of cool. Look, this, you can also do this in Python, Harry. Put it in the watch and ask the debugger to make the operation, multiplying. So this will be, Harry, 33 lines. This 4 will be computed 33 times. 33 lines. Why? Because in the screen you only have 33 lines at a time. You only have that. So that makes sense. So in the next line here, initial row will be 1. Why? Because this thing is going to be 0 again, and this file will be, this fila will be 1. This will be how many? You will see how many right now. This is 0, but when this is going to be 1, this will be 120. Why, Harry? Because the line is 120 long. So the next line is going to start. See, Harry, it's working, right? It's kind of working. This fila will be 1. This is going to be, when this fila is going to be 1, will be this one. So when we multiply this, I mean, doing this operation, this one. This doesn't care right now because this is 0, as you can see. And in the next iteration, the fila will be 0 as well, because we are in the first layer, Harry. So don't pay attention to this. Let's make this one 0, of course, but let's substitute by the value we already compute. This one, right, Harry? Why? Because see the variables. This will be 1, this is 120, this will be 120, so this will be 120. And that is correct, right, Harry? Why? Because we have, in one single line of tiles, we have 480 bytes. Remember, Harry, we need to switch from tile to bytes. And we know that each tile has 4 bytes. So we just multiply 120 for the number of bytes each tile has, and it's that 480. Yeah, it just makes sense. It's just simple arithmetic. You can see just multiplication and addition. Oh, what a mess. Okay, let's continue. Initial title. This will be, in the next one will be 0, because we don't move the camera, so it will be 0. And initial byte string will be this value, because it will be 0. So no computation. That is correct, Harry. Yes, that is correct. And it still is correct. Still is correct. Why? Because we are still in the first column, Harry. The first row, the first column. No, sorry. The second row, the first column. And of course that makes sense. Yeah, continue. Okay, ignore this. All these are ignored because we are not using. Initial column here will be column 0. This will be column 1 in the second. The initial row will be an offset of 480. And the offset, oh, I see. Hold up. No, it's okay. It's okay, Harry. Wow. Okay, let's move to the next iteration to see the fila and to proof of concepts. There we go. Now fila is 1, sorry, it's 1. So as we can see here, we have here, Harry, we have the initial row as 1. It's the second row. Perfect. Then the string row will be, of course, 120, because each row has 120 tiles. Perfect. The initial string byte. Wait. Harry, this is the problem, Harry. I mean, I'm crazy here. What is going on? Harry, see it. This is the problem, Harry. Initial string byte is 0. That's That is not correct, Harry, because this is the second row. It has to be different, right? It has to be like we compute here. Here, Harry, here. Here, just right here. It has to be 480. Harry, yes. See? What happened? What? I mean, I'm crazy. Harry, are you seeing this? The same thing I'm seeing? This value is 0, but we have here. Hold up, Harry. Hold up, Harry, hold up. This is 4, Harry. This thing is 120. Yeah, so if I multiply these two, hold it, Harry, hold it. Harry, why is... Oh, I know. Here's... Oh, no, Harry, yes. We make a mistake, a huge mistake. It has to be plus. Of course it's 0, Harry, because this is 0. And we substitute this value here on here. That's why. Okay. Okay, Harry, let's do it again. Let's do it again. Now I have more feeling. I had the feeling, Harry. I think now we will see something. We will see something, Harry. Yeah, kind of silly, right? Oh, come on. Let's see, Harry is in black now. Yes, Harry. See, you see, Harry. Are you watching, Harry? Yes, Harry. I think we did it. We did it, Harry. I mean, Harry, look, it's kind of, I mean, it's what we want. Yes, Harry, yes. Yes, buddy. You rock. Ha, I knew it. With you, I will do it, Harry. Oh, yes. Thank you, man. We did it. Oh, come on. This is kind of exciting. Yes, awesome. I mean, look the tile. Look the tile. Look here. Look. We are here, Harry. We are here. We are here, Harry, in this part. In the render, we are here. Let's see. Yeah. We are just there. Yeah, has to be. Excellent. Let's check. Yes, it's the same. Perfect. Okay, Harry. Okay. Oh, if we move the character, of course we will see. Yes, Harry. Look. There is no more war because we hard code the position of the camera, Harry. That's why we don't have more war. But it's not war, Harry. Let me see. See this weird part. This tree. I don't know if this is correct, Harry. Let's check. I know you can see this tree, Harry. I am close to this tree, which is cut. And I think in tile for the first, see in tile, Harry, here. See, this is the tree, but in the first it's complete. Why I don't have it complete? That is the question. Let me check something. Maybe it's because, let me check a bit. Maybe it's because map properties. Oh, I know what is the problem, Harry. We are rendered just not the whole part, not the whole roads. This is the thing. I have an inconsistency from the from tile. Let's say from the map of tile and my camera, because my camera is not done. The height of the camera is not equal to this, because as you can see, Harry, this is 40. And do you remember how many rows we are render? Of course you remember. We are just render this amount of files of filas, and this is it's not available. It's because it's not that. Sorry. And we are not here just yet. There we go. Look, 33 out of 40. That's why. Okay, that doesn't matter, Harry. That doesn't stop the party. Yeah. Doesn't stop the party, because it doesn't matter. We just need to fix that. Oh, now let's do something, Harry. Let's check something. What happens if we change this hard code and we actually read the position of the camera? What is going on? What do you think is going to happen? We will render the whole work? We will see the whole work? Huh, that's the question. Let's try it, Harry. This will be exciting as well. Okay, there we go. This is the viewport of the camera. I can show you the function. This is going to return the viewport of the camera, but dynamically. Okay, I mean, when I move the camera, when I move the character, actually, the camera moves as well, of course, because it has to follow the character. And this function, Harry, will give me that viewport, that position. Every frame, I'm going to read it, the position of the viewport, and I'm going to render the map. Okay. How is this viewport computed? Very easy. See here, the position is based on the position of the camera. In the position of the camera, I send the position of the character, just X and Y, because it's a 2D game. Just send the 2 and Y, the X and Y. Then I compute the position based on the center of the screen. That doesn't matter, but this is the variable I would like to show you. I take the coordinates and then I add up the width and the height of the cane. Okay, which is these values. It's kind of simple, and with this I already have the viewport. That's all. It's very simple. That's very simple. Okay, let's repeat this exercise and see it. Yeah, we need more roads, definitely. Yeah, but let's see. Just let's see, Harry. Let's see. Okay, it's stopped because we have a breakpoint there. Okay, let's play. Oh no, we failed. What is going on now? No, unbelievable, Harry. Oh, wait, Harry. Wait. I think maybe it's because we have a bug in the position of the character. I will move the character. Yes, Harry. Yes, that is the problem. It doesn't matter. That is fixed very, very, very easily. But look, Harry, I think we have more war now. Oh my goodness, we are moving to the war, Harry. We are moving to the war. Oh, but there is a problem still. God damn it. I mean, just ignore the fact that we are seeing like a red square at the end of the word, because I think I have some modification left. I can show you. But we still have a problem here. Yeah, we still have it. But first things first, I will show you. No, I thought we have it here. The position based on the scale. No, 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 no. It's based on the position. Anyway, so that will be another things. I don't know exactly now, but I will see the next problem. Damn. But we are almost there, Harry. Almost. What is the next problem? What is the problem now, Harry? The problem is that we have all the maps sequential as well. See this. If I go, I move to the south, to the south. Yes. I don't have more data. I don't have the data. Where is the map here? See it? It's just one. It's just information of some layers, not the whole layers. These are the foreground. Do you remember, Harry? These are the foreground. Because I don't have ground. But if I move to the right, I have this, which is correct. But I shouldn't have this. I shouldn't have this one. This one, Harry. Yes, right? Let's check again in tile. God damn. What is going on now? Let's check. See it? I mean, this is right. And you have these things which are from the ground. No, this is foreground. But you don't have the ground at the bottom in this direction. But you have here this one. Wait. Okay, let's try to remember this, Harry. Let's see. It's possible to put in here so you can see. It's not allowed. It's not allow me. Okay. Let me see. Yeah, you have this one. This. And then it repeats, right? It's the same, right, Harry? Right? It's the same. It repeats. This second one, it repeats with this one. And if I continue moving, what happened? It repeats again. What? Yeah. Why is there that extra repeat in this? I don't know yet, Harry. What? And I think it's infinite. It's infinite looping. See? It keeps repeating, Harry. God damn. Oh my god. What is infinite? Now I have an infinite map, Harry. What? And it's repeating below as well. Look, Harry. Oh, come on, man. What is going on? I know, Harry. Maybe I know. I know what is going on. What could be the reason, Harry? The reason is we are not using the final task. Do you remember that variable that I told you? We are going to use this later because we need to first and blah 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 blah. But the final, yes, Harry, that could be the reason. If you don't have any part where you stop reading, you continue reading, but you are reading like in a round robin way, right? Like like repeating when you reach the final and repeating, repeating, and repeating. What a weird behavior. Oh, come on. Anyway, Harry, but we are just this close, Harry. I mean, just look at this. It's almost there. And another thing is we have to fix that thing. That red line that appears at the right. But okay, but it won't stop exactly. Well, but this is the principle, Harry. This is the principle of making a game like it's a open world. In this case, is it's a 2D game. But I'm not willing to make an open world game at all, Harry. This is just a strategy of big maps. That is the name, big maps. And what you do is just having a really large area, like you feel like it's an open world, but then you split the scenes by loading another map and in the flight. So it's not like an open world, but this is the essence. Yeah. Damn it. Okay, how to fix that? That would be the question. How to fix that? Where could be the fix of this? It's still a weird behavior, Harry, because why is continue making and just remember this, Harry. It's not like repeating the first one, it's repeating the second one. That is even weird, right? Why is repeating the second map, not the first? If it's started from the beginning, why is not repeating the first? Why not repeating this one? It's repeating this one. Another thing that I need to do, Harry, is to try to change this map because they are too similar, right? It's also a problem. They're too similar. Damn. Ah, crap. But this will make this is a lot of time for me because I'm not that handy doing this stuff. So I will do it maybe offline and I will continue coding. Because of course, you know what I'm doing as well, Harry, but I cannot integrate it right now because I don't have time yet. I don't have the opportunity. I'm trying to do a building tool. A building tool is I don't know if you are using any IDE with Python. Are you using an IDE to code in Python, Harry? What are you using to code? Visual Studio Code, or are you using maybe PyCharm? I don't know. What are you using to code your Python exercises? Anyway. I will be using PyCharm, but I get my computer tomorrow. I've been learning from my phone. From your phone, Harry. Wow. Respect. Respect. Yeah. It's been so hard from my phone. Yeah, I can imagine, Harry. I respect that. Yes. My friend, I really want you to advance in your learning. That is, yeah, it's not easy. Yeah, but well, I think if you are going to use PyCharm, you will understand this very easy. The, all this ID has build tools, and these build tools are for making it easy to construct the program. So I want to make a build tool, a simple build tool in Python that help me to decide how to compile the game and other stuff and other tools just on the fly. And I will integrate with Tile, and it will like Tile is going to make, it's going to be like the IDE for designing. And when I compile, it's going to compile the code, and it's going to run the game, and like this, like Godot or Unity, something like that. But I haven't found the time to integrate the tool. I call it Voila. Okay. But yeah, I still I still trying to find the time to integrate it. Anyway, how to solve this? How could be the problem? This is kind of tricky. Why is repeating the second part? I mean, we have here, Harry, the right computation of the initial stream byte because it's working. But could be related with the columns in the row. See, Harry, the thing is, when we render, we need to say to the render, what are those positions where the render is going to render the images. And because this is styles, I was just about to say that it doesn't make sense to be repeating the second part, right? Surely it will repeat the first exactly. The first and then probably the second one, just repeating the whole word again. That makes sense. But why is doing this? Ooh. This is the tricky part, Harry. Having this kind of, finding this kind of books is like, wow. Because this I call in runtime errors. And the runtime errors are the worst, Harry, the worst in programming. Because the program is working, but it's behaving, yeah, randomly. Are the worst, Harry. Trust me. Ugh. I don't even see what could be the problem. I mean, in my mind, I can figure out how to spot the problem. Because we first start from here, and then we take the information. We copy the row, just the row. Remember, the rows are 16. Each row has 60. And I know, I told you that is 120. But that is for the whole word. You have to remember that we are taking just the part we are render, and that is the camera, and the camera is 16. Why? Because as you remember here, this one is this amount of pixels. But if you divide this by this, you will have this. Okay, so that's why. That's why here is it's a 16. This is not the proper code, and by the way, Harry, this is not good to have it. This one, because this is hard coded, and this is called magic numbers. You have to avoid magic numbers. It like bullets. You have to avoid to have it, because this is just makes sense for you. And when another programmer look your code, he will say, what is this magic number? Just doing magic there. It's not even a variable to have with a name that explain me why you have that number there. So this magic number is not the proper way. Of course, I'm going to change in the future. But remember, no magic number in the code. Okay, so I'm taking the first row, which is equivalent to have the first row of the camera, which is 60. Okay, then after that, I will iterate for the same amount of tiles. Of course, it just makes sense. The same amount of tiles, 16. Okay, I take the first with 0 number, and then I process. This is kind of straightforward. It's just taking the column here. This column, you will figure out what this column is the initial column, Harry. In our nodes will be this one, initial column, but not, watch out, not in bytes, but in tiles, right? Because that it makes sense to have tile coordinates, no byte coordinates, okay? So it's the initial tile. That means here, this value, when this is 0, this will be the column 0, and in the column here, we will take that value, and then we will start in the 0 position, multiplying by what? By the size of the tile. And the size of the tile is 16. So of course it will be 0 in the first position, and the tile position will be 0 by x. And that is the same for y. Right? When we compute initial tile row, yeah, feel it's okay. Row, and row will be computed here, and again multiply it, blah blah blah, and then we will add up the line when we move to the next line. Yeah, we are out of the 4, and yeah, that's it. I think the render part is not the problem, Harry. No, the render part is not the problem, because there is not too many variables to deal with. Has to be something related to the string here. Oh my goodness. No, Harry. No. If I don't have problems, I mean, saying that I don't have problem with the render is equivalent to say I don't have more maps in the game, but I have more maps. So I also have some aspect to tune here. But what could be? Position 0. Yeah, position 0 is okay. Tile buffer as well. Wait. No. Because column is computed with this value, and this value is dynamically assigned here. Yeah, no, it's okay. Mm, wait. Weird. This is weird. I think this is an error. Okay, this could be another thing, but I think this is an error. Let's check it. Put here, here. There we go. Collapse this. Look, Harry, this is an error as well. Deep concentration, yes. Oh my goodness, but this I think I spot another issue because look, I mean it's working, but this code is weird. Look, I'm taking the initial row by assigning this fila to this thing, and then row is taking this because of course it's the right row, but then after that code I am adding up this variable, and that doesn't make any sense. I mean, it's not hurt the code, but this is not doing anything, Harry, because when I reach this part the code, I'm taking that row and doing iteration through the column and taking the row. I mean, the row is kind of fixed inside this loop. You can see the column is the only one that is incrementing, and the row I keep in the row, the whole loop. Dun, 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 dun. I render all the tiles, and then I go out to the 4, and then I add up this here, added 1, incrementing 1, and then I repeat the code here, assigning the row here, and this doesn't do anything, Harry. Just erase it. That doesn't fix the problem at all, Harry. It's just wasting instructions. We still have the problem. But maybe now we can spot something else. I will try to to write down this code to have like clear vision or something. Okay, at the end. Now, for a moment, I thought maybe we could do a test saying, okay, when I have more columns, when I render more columns that the world columns, like more than 120, we can make a break in the program and then see what's going on. But that is not possible because, or maybe, what is the maximum coordinate of a column according to the world map? Will be a 121 column, right? Yeah, Harry, I think we can make a test here. See the state of the variables. This is my plan, Harry. This is my plan. We are going to break the program when the column is 121, and the program will stop and we will inspect the state of the variables and see why we are render more things. Yeah, I think it's a good test here. Let's try it. Let's try it. I will show you, Harry. I think this is a kind of nice, also nice. Feature of a Visual Studio. I mean, any ID, you can do this in any ID. I will comment this line because I don't have this variable now. And I think that is enough. Okay. Okay, Harry, if you are not there, but you can see in the broadcast, you will see this nice feature and the debugger. We will do a conditional breakpoint. And what is that? We will make a breakpoint that interrupt the program when a condition is met. And these kind of breakpoints are kind of nice because they are like, in a sense, very precise. Yeah, because we want to make a break when the column reach a certain value. But of course, we can do this by making an if and say, okay, if column is equal to 121, we will make here a dummy variable and we will stop in that there. Yeah, I mean, it's possible to do it that way, but this is more professional. You will say, we will open this part, we will take the variable, and we will hit here, right click, and we will say add conditional breakpoint. Boom. And we will say this, and we'll put in here like instructions in C++ or in Python in any program language. When the column reach this value, break. Perfect, right? So let's check it. Why is not break it? I don't like this. Why is not breaking? Okay, let's disable for a moment. It's not working. Just happened. Weird stuff. Why did not break? I don't know. I don't know. But it also has a weird behavior. So now is okay. So now we have the game running. I will activate the breakpoint. Let's enable the breakpoint. And it's like it breaks, but Visual Studio is unable to attach the process. That is the technical definition. Attached to the process. And I think it's a problem with Visual Studio. Of course, it's being a free IDE or no IDE, an editor. So the things you have, right? It's free. But it should stop. I mean, actually not, because we are not in this value right now, because this is kind of what could be this value right now? 16 instead of 120. So it's not even possible to break in this moment. My plan was, if I move to the right, I'm going to have this amount of values, range values, when this condition could be met. So that probably will be the time when this breakpoint hits. But it's not working, Harry. See, this one is working. And when I check the values, see, it's not even close. And I think it's a continue iterating. Wait. Harry, see. See this thing, Harry. See this value. Harry, I think we spot some possible hint. Harry, listen to me. If we reach this kind of values, that means that's why we have this amount of infinite maps. Here there is a problem, Harry. Okay, I think we are close. We are getting close, Harry. Why? I mean, this is. Oh, sorry, Harry. You can see it right now. I will put in the value here so you can see it. There we go. There we go. See this value, Harry. I'm talking about this value. See how big is that value? It's a huge integer, and that's why we have these infinite maps. Why? Because if we reach that value, Harry, just imagine if I multiply that for 16, it's even bigger. So that's why we have this render going infinite to the right, because the columns are infinite. I mean, not infinite, but that amount of columns is kind of big column. Yes, Harry. Why we have that number? No big number. This is called corrupted data, Harry. Corrupted data. Our program has corrupted data. It's in a sense corrupted because it's out of the range we expect. So we corrupt in some places. We corrupt this data, and precisely is column. That's why we had these huge maps. God damn it! But see this initial column, Harry. Wait. This could be because we need to move. I mean, to hard code again this part. This, but not put it in 0, put it in some place, some another place different than 0, because I think we can make it this here. No, before that, let's make it this here. let's move the game to the left, like here, and then break it here. Okay. Now inspect the values. Yeah, these values are more sense, but what happened before? What happened before? Let's explain. The problem, Harry, is here I'm using variables that are unsigned variables. And what that means is, I told you at the beginning of the streaming, I was telling you that a byte is a number that has 8 bits. 1, 6, 7, 8 bits. Okay. So when you have unsigned numbers, Harry, the last bit, this one, is taken to make numbers, to make combination of numbers. Do you remember I told you that with one byte you can use to have 256 numbers, and if you have more bytes, you have more numbers and stuff, right? But that is true when I have unsigned integers, because when I have integers with sign to have negative numbers, this bit is for knowing if that number is negative or positive. If I have a 1 here, that means this is a negative number. This, of course, doesn't make any sense, but this will be -0. Doesn't make any sense, of course. But let's imagine we have this one. Okay? This will be -1. Because this is an unsigned number. If I render this like unsigned numbers, like signed numbers, that would represent that. So that means when you have signed numbers, you only have 7 bits to make the combinations. 7 bits. Because this bit is for the sign. Okay? So that is the problem to have that big numbers? Yes. Because when you have this this bit here activated like 1, that means this is not 1. This is a big number. It is almost the last number of the scale. This corresponds to this corresponds to 129. 129 number, not the one. I mean, when signed numbers, these represent -1. But with unsigned numbers, these represent this number. See how big is this number? This number related to this number. See how big it is, just because this number. So when I assign, when I take unsigned number, this U is for unsigned, and I make this value. Oh, hey, Nukebird, welcome in. Thank you for the following, man. I was just explaining unsigned numbers, and nice to having you, man. I will continue explaining this, Harry. This is -1, right? This is -1. So when you assign this, you will have this value instead of -1. So you don't have -1 as a value for this unsigned number. Okay, Harry? So that means if I have a big number, like here, big, very big number, like this, I will start having -1 for a signed number. But for a unsigned number, this will be very big number. Okay, that is why we have that. New bodies unite. C++. Yes. Here we are learning together. And yeah, that's it. That's it, Harry. That's why we have this mongoose number before. But that's why, because again, do you remember the problem I described you when we have this? I hard coded the position of the viewport because I know that we have that problem, and now we are facing it. But yeah, so that means the test is not going well. The test is not going well. That is the summary. But that is the theory behind the signed numbers in C++ and in any language actually. Well, maybe in languages that use data types, probably. Because in Python, I think in Python is dynamically assigned and it's put in the right position. So let's go back to this and let's go back to the test. So look, we are trying to figure out why we have an infinite map. I will show you. I will show you with this. And I'm going to move the character. Sorry, why do I need to disable this? Why I'm here still? There we go. So let me move the character. So as you can see, Nuke, according to our data, we only need to have these two areas, this area and this area. Okay. So, but as you can see, we are having infinite maps. You see, we are repeating the second area. See it? Why we have this? See, it's infinite. And we only have this one. I will show you in Tile. In Tile, this is the Tile Pro. This is the program I use to edit my world. And they are just like this. The first area, the second area, and this is the third, and this is the fourth. But they are having another type of problems, and we are repeating this area over and over and over and over and over again, which is weird for us. And yeah. So now we are trying to figure out that, and we are spending some time doing this. We fixed something in the streaming today, and we are very happy with Harry. What we fixed? We fixed. We were rendering the map in the wrong way, so we have several tiles in the wrong position, and it was like having like a glitch, very weird. But we fixed it. But now we are facing this problem. And we were thinking that probably one of the problems is we are not saying when to stop. But also that doesn't make any sense. Because we are taking the position in the binary stream, we are taking the right byte, because we know, because the map is rendered properly, let's say. For ECC, are you using external lib or did you write it? No, I am using external ECC. I'm using entity, the C++ entity. This I can show you. Let me. Do you know it? I can put it the entity. I can put it the link. It's a GitHub repository. I'm using the entity library they have. This guy have. I think it's quite nice. And you have also several wrappers if you want to do it with the C# as well. Ah, you know entity too. Yeah. I'm using entity right now. Yes. Entity X flex. Exactly. Okay. Yeah. I see you have touched it. I see it. Huh. Yeah. So when you just arrived, we were speaking about trying to have a breakpoint that is conditional, so we can say, okay, when column It's set to this value, which is the final column. The column has to be 120. We will break, and then we will inspect the state of the variables and see why we are having more than maps we expect to have. But the debugger is not working properly. It's kind of weird. If I edit this breakpoint, maybe am I doing something wrong? Probably. I don't know. It's like it's weird. It's a weird behavior here. Because if I enable this, I do not stop. I do, but the game is start like rendering slowly. It's like it's actually breaking, but why? Because I don't have exactly that value in memory column. So that is the thing we are analyzing. Could be. I don't think so. I didn't change on the fly, right? Should I change the condition? Yeah, it's rendering very, very slow. This is kind of weird behavior in the debugger. Yeah, it's not working. Let's do it in the old way, okay? Let's do it in the old way. We will do it like this. Stop this. Do it like this. Let's see if the compiler doesn't optimize this. Okay, let's check this. Yeah, infinite map glitch. It's official. Let's put in the description of the game. You have infinite maps. See, now it's not behaving weird. Okay, so if I move to yeah, there we go. We have the breakpoint. I guess. No? No. So it's too precise. Wow. What? Oh no. Let me see the next one. There we go. We have it. Excellent. There we have it. Okay. So let's check the state of variables. 5. Okay, yeah, that's possible. 62 initial column. Wait, what? Oh yeah, 62 plus 60. Yeah, it's okay. Yeah, it's okay. Ah. 62 plus 60. These children. Oh, now I see it. Now I see it, guys. Of course. Of course. 62. So when column is 62, the binary here will be this. Oh, of course. I think I can see it, guys. Okay, I see it, guys. Why exactly 16 elements in the man copy? Because here I have a version of this map render that takes the row first. It's row wise, and the row is 60. And why is 60? Because that is the width of the viewport. I'm rendering just the thing I'm seeing. That's it. I know it's kind of early optimization, but since I think it could make work, I will do it right away. That's why it's 60. I mean, it's a magic numbers. I explained to you, Harry, right? Magic numbers is not good. It's better if we have a variable to explain what it is. But this is because the viewport is 60 tiles at a time per row, of course. So I take one row and then I use that row to render, and I move to the next row and then 60 tiles in that row and then render. That's why. Okay, so the problem with this is this one. Listen, I have explained this code before, but I can explain again. We tried to compute the initial row by knowing that we have the position of the camera, right? So and the coordinate of the camera are in this variable, in this structure, and we multiply by 16 because the 16 is the amount of, if the size of the tile, and then we use this initial row and multiply it by the size of the world. I mean the width of the world, the whole world, and this is 120. And this is the, let's say, in tile coordinates, the initial row. But of course, we need to change that variable in terms of bytes, because of course we are dealing with a binary string. And I was Harry and I were talking about this size stuff, and we are having in the binary string data coded in 4 bytes. Each number is 4 bytes for us. So that's why we multiply the amount of tiles by this size, because of course it's the size of data, and we have the exactly byte to begin in the binary string. So that's working. Then we need to move the exact amount of columns ahead after the row, because of course it's not equal to have the initial row to have the exactly column in that row, right? So we compute also the column and we multiply that by 4 again, or by the size of the data. In this case is a binary of 32 bits. Sorry, a number of 32 bits. And then we have the exact byte where to start. Perfect. All these variables are not used yet, so just try to ignore. And having the initial column and the initial row, we have the initial column to render and the initial row to render. So those are in tile formats. That is correct, because of course we need to make the rendering, and for the render, we need to specify exactly the tile coordinates. That is correct. So finally, we take the byte, and that is our offset. And we use this offset to address the... Oh, Harry. Thank you very much, guy. I appreciate you came again to the streaming. I really enjoyed you having chat with you, and also thanks for helping me to do this. You helping me, Harry. You don't think otherwise, because having a conversation about these things is also helping me. So have a good night, man, and have a good rest. See you next time. Okay. Okay, so after having this, I address the binary string and I copy 16 because that is the amount of is the amount of tiles I will render according to the camera. 16, of course, by the size of the data, and that is the portion of the binary string I need to render. That's it. The problem here, Nook, is I didn't realize at the beginning that when I move, of course I ignore completely because I ignored this part completely because I wanted to make this work first. But of course now the problem is, Nook, that when we reach the point when we have already this amount of data, we are moving to the next row. I don't know if we are seeing this. I will try to put in this in the comments to explain myself. Is this thing in the initial column? If initial column is 62, let's say 62 plus 60 is already now this one. So, but each row has 120 tiles. So I have two ahead. And these two are for the next row. And that's why it's repeating. That's why. That is the reason, Nook. And here is when that problem happened. So what I need to do actually is to make this variable work. That is the thing. I need to compute the right boundaries. That is a good idea. If I do this. Oh, but if I do that, I will go back. I will go back to the model. To keep what exactly? I mean, the model is a good idea, definitely, because a model clamp the numbers. Yes. It's a good idea. I also can use clamp. Also possible to use clamp. But where exactly, Nook? Where do you think we can apply this? I mean, here if I have already more than 60, the camera will take the offset and it will get crazy. Yeah, if I already have more than 60. Yeah, this is a common problem in this kind of game, I will say, because when the camera reach, well, with you can do that tile, let it see it, yeah, it's a good idea. Look, definitely. I'm trying to figure out where to clamp this. It could be in the column, yes. It could be in column. But I think if it's in column, I will just I will just go and I will not try. Let's try. What happened if we add column here? We make the model. I mean, like column equal to like this. That will keep column inside the boundaries. But of course, just imagine if column is already 21. This will be 1, right? With the clamp, this one. And we will get render the first map. We will repeat in different way. It will repeat, right? It will repeat. It will repeat. So it's kind of saying that stop rendering and we will start rendering the red area. It's kind of like this. We need to make this, but let's try this. This will be funny. Yeah. It's a really good idea, Nook. Yes. Where to change more? That's it, right? Okay, let's try this. It will repeat. Yeah, it will repeat the first part. But I would like to see it. Exactly. It's basically how you use in your OpenGL repeats. Yeah, exactly. There we go. Okay, this is the second area. Nook, what is going on? Nook, hold up, Nook. Why is not repeating? Nook. I mean, no, you also expect it to be repeated, right? Tell me the truth, Nook. You also expect it. I mean, what? You are a genius, man. No. But tell me first. Tell me first. You also expect it to be repeated, right? No. Tell me. I mean, why is not repeating now? What? No. Wait. Oh, of course it's repeating, but it's outside the screen. Here. Of course it's repeating, but outside the screen. Because it's repeating in the first column. And so we cannot see it because the camera. But it's repeating at the beginning. At the beginning, I mean at the left. It's repeating at the left. Yeah, now I see it. Yeah. Yeah, but the solution is almost there. Yes, it's true. It's true. Yeah. Look, here is, I think it's a different problem. Here I don't have actually this could be the same problem, but it's repeating through the rows. Let's do the same solution, but for rows. But the road is here. Yeah, entonces with row is I think this has to be 33. I have a book here as well because this has to be 40 actually. But yeah, let's keep it 4. And 33. There are actually other solutions. You can somehow find the general size of your map when coordinate exceeds the limit, just to break and continue. Exactly. Yeah, that is another solution. Actually, I have a similar solution here. When I reach the end of the stream, I just break because if not, I'm going to read. I'm going to have a violation of access memory. Yeah, it's true. True. And I think that could be the better solution, right? Because if we break, where we need to break here, right? If we break here, we will not get repeated. Yeah. Let's try that also. Nuke. The size of the map. Wow, it's actually saying this, right? I also have this value here, I believe. Here. So I can also put it in here, but I'm putting just magic numbers and then fix it later. Something like 0, 0. True that. Using the x coordinates work with in terms of yes, also true. Yeah. And rows. I don't remember how many rows. I will also use that solution here. Look. Saying that rows big than these columns are big than this. Actually, than this. And this, I think I have it now in one place. Layers, I think are in here. I'm not sure. I will check it. Yep. Break. $116 billion bound. I will say yes, because we start from 0 to 120, but it doesn't include 120. Yeah, I will say yes. Oh, yeah, I know what you mean. I know what you mean. No, it was okay. I was thinking something like that, but no, it was okay. We reached that break. And with this, I think with this it's the same. But this height, I don't remember this how I code this how I encode this data. I don't remember if it's I need to divide by 16. Checking zero is also important. Yes, it's also important. I don't check in here actually, but yeah, can be negatives. Yes, because I just render in the positive part. Yes, you also right in that part. But I'm trying to just fix this first. But when we have 0, row could be 0. Yes, but row could be negative. Yes. I mean, yes, but yes. Let's try this, because I had two type of data encoded. I have in tiles, and also I have in binary, and I have also in discrete formats. So I have 3. Yes, you are right. By now 0 is all right. So no, you are also doing C++ for something. It just rendered the first three. Why? Weird. And now 0. Why the first 5? Hobby and on my work I started in. Wow. I mean, you are working in a studio. I don't know, indie studio, AAA studio. So you are kind of professional in this field, right? Software developer probably, and then or you study or you started you started in. Oh, I see, I see, I see, I see, I see, I see. So you're similar as me. I also work as in the company software, and I do other type of software, not game, and I do this for hobby and also because I like it. So you have a similar profile. Yeah, yeah, yeah. I see. So you started as a hobby game dev, indie game dev at 209, 2009. Sorry. Uh, well, yeah, that's a lot of time. Yeah. So you have very, you have some games, maybe a game around who learned C++ by myself. Oh, I started, but not at 40. I started at 17. Now I am. Oh, okay, I see. I see. I see. Ah, nice. Kind of nice. Yes, I remember a friend of mine told me that, you are going to study computer science. Well, it's good idea to learn C++ and just give me C++. He gave me a book, which is called Data and Data. That was the book he gave me. How to go in data in C++ by data and data. I still remember that book. Oh, so why is this coding? Maybe it's because of this. I will need to check this data. So, and you are also interested in using ECS, right? Nook. Yes, this is the problem. All this. And let's check again. Aha. It's not render because it's break. Breaks there. And then this part is working correctly. And we still have this problem. Okay. But I think it's working. Thank you very much, Nook. Definitely you helped me a lot, man. Thank you, thank you, thank you. Yeah, it was actually there. Thank you very much. But I felt guilty not trying it. In fact, I was scared of C++. Everyone was. But then a friend gifted me a C++ book. Nice. I think those friends are, yeah. Cheers for those friends. Fun fact, I was just gathering dust. And then you need to the toilet. What? I need to the toilet? No, no, please. Don't tell me that you did something wrong with that. You use it for other purposes? No. But I feel guilty not trying it, so that's why I learned it. Good. Yeah, I do like idea. Oh, see, I see. Close to the toilet, man. Okay, I see. He gave me a book that his family never read. His family never read it. I see. But nice, nice. Similar history. So yeah, look, I think it's working. Look, I mean, not still that, but yeah, it's quite close. Now I need to figure out what's happened with this part. But this part is different. Look, see, is this part is the problem is I just it's like ignoring some data because of course I don't have ground. It's ignoring data, but I don't know why. It's like having zeros. You know, I told you, or I don't know if I don't if I told you, but I'm using this, right? And when I don't have, since this has layers, in some layers I have zeros. Just render this, for instance. See? And in all this area is zero. And I know when I have a zero, I just don't render anything. And this part is like this part. See? It's like ignoring data, but I don't know why it's ignoring data. Because I know I have all the data encoded, like in these parts, like in this. Maybe I will check. The first approach will be check if I actually have the data there. Yes. Look, I will explain you my whole workflow. Okay, I'm doing the custom render, right? That is a fact. But I decide to use a general purpose editor, which is Tile. Tile gave me this gives me the information of the maps in layers, or if I want, and encode that data because I decided encode that data in in a format in base 64. Anyway, I use that data in Python and I convert that data to binary data and I save it in a file. And maybe in that process, I'm failing something. I can show you the Python data. It's not even a huge deal. It's kind of simple. And I will show you the serialized Python. The main Python. This is the program in Python that take the data Tile gives me. I compose the world by taking the layers. I mean, in Tile there is a concept calling world, and you compose a world using maps, small maps. Of course, you can also have infinite maps. You can also have it, but I decided to take the approach to have pieces instead of a huge amount of pieces, because maybe someone can help me in the future, I don't know, to make portions of the maps so I can work with this partner. I don't know. I don't have any partner, but and say maybe you can work in this part of the world and I can work in this part of the world, and then when we join all things together, we will have this. I decide to do it that way. Okay. So I compose all of this thing in a class in Python that I call world. This. And the world layer, the world class, sorry, has an struct type of data in Python that allow me to write the data for C++, because using this I can decide how the engine is. I can decide the type of data I want to store, like encode the bytes if I want 4 bytes integer, so I can decide to do it and stuff. It's kind of flexible. This is the way to make Python to communicate in a binary way with C++. So I take all this information and I code it in binary and I save in a file, and then I use C++, the part you see. Sorry. The parts you see in C++ to render. That's why. So probably Nuke I'm making mistake here. I ignoring the two last maps and not writing the data correctly. That's my assumption. That is my assumption. So I will check the Python code first and see if I actually have the data or write the data correctly, which is in serializer. Here in serializer, is this actually here? Yes, it has to be here. In serializer, I have meta file. This is not tile file. This has to be. This is the file. Is there a way to draw only stuff from a specific layer just to double check yourself? Yeah, there is a way. You're clever, Nook. I think I understand what you're saying. Let me check. Render system. Render system. Here. You mean here, right? I believe. Here. The layers are here of the world. So if I put in here the first layer, one, I will just render the first layer of the whole world. If I start from 1 and say 2, I will just render the second one. Yeah, that is a good test. Definitely. Look, good idea. Thank you. Let's render the first one because I believe the first one is the problem. The first one, why? Because what is not rendering is the ground. This thing is the ground. And similar with this. See? I think the first one is the problem. Yeah. Definitely a good idea, Nook. Okay, let's check. Yeah, you are good, man. Definitely. Thank you. Good test. Okay, for the first one, I have it. I mean, actually, we have it because we said it. We saw it in the... But here... No. No. Are you watching this? I think the problem is I am messing with the data in the fact that I am actually not taking the ground layer, and I put in, instead of the ground layer, I am putting the foreground layer. Look, man, yes, thank you. Man, you are good, man. I will invite you a beer. Well, 29. Yeah, you can drink. No, you deserve a beer, man. Definitely. Yeah, that's it, man. That definitely has to be. Yes. So it's definitely the serializer. Definitely. Has to be the serializer. It's not other possible. No, there's no other possibility. Yeah. Yep. Has to be the serializer. Man, what a good test. Yes, definitely. Very good tester. You know, I will release this game. I will be honored if you test it. If you test it, if you play it and say, oh yes, this one. Definitely. You are very good, man. Okay. So where is my problem with the serializer? Where is the problem with my serializer? Okay. the layer index. Okay, I know here I send the layer index. I will say this is working. I mean, sending the index because the second map actually have all the layers. I think. Mhm. Okay, this filter. Could be the filter. How could I test this? How could I? Mhm. Am I skipping the layer index? If valid, what if we have it's not valid? Well, if it's not valid, that means that I'm taking more roads than I expect. So I code these functions to make me um, to give me some information about the sizes. Of course, if for here would be better, I believe, to raise an exception, probably. I haven't decided, so I just put it in here. But it's always valid in this kind of context, um, because I pre-compute the amount of rows previously. Well, according to my understanding, maybe probably I'm doing something wrong, but what I'm thinking is why I skip some layers, why I smash a layer with another one. You know what? Probably the problem is when I move the offset. You know, Nook, when I write this data to binary, I can show you actually. This, I think this one is. This is the format I received from Tile, and this is the information encoded in base 64. You can decide which code you want to receive. I decide to make it in this way. So, of course, this is a JSON file, and since I want binarize this, I will. What I do is take the first layer and write it in the file, and then by an offset, I put the second layer sequentially, and then I move by an offset and then put it in out. And yeah, that's it. So probably I am not moving the offset when I write the third one, could be because the first and the second is working. No. Because I also had to do some magic here. I will explain you, Nook. Your layers are going to be brutal. Yes. Oh gosh. The thing is, Nook, when you compose, I mean, when you take the average I'm doing right now, because again, you can do this infinite. Each portion has 5 layers, 5, and 5. But of course, the layers ends here. The first layer of this ends here. And then the second layer, of course, ends here as well, but it's just for this portion. But of course, I don't want to have it in that way when I render. I want to have the layer to continue to the corresponding layer to the next portion. So the first layer here will be ground, ends here. And then I move to the second portion, and I take the ground layer and connect with the ground layer of this portion. And then I continue. And I do the same for the all layers. So as you can see, when I receive the portion, split in the JSON. So I need to move from the first row of the first layer in this particular example. And then I move to the next data in the next portion, and I take just the first layer of that layer, just the first row of that layer, connecting with this and right into the disk. Hopefully that makes sense. Why? Because of course to render, I need to do it in rows, and the row has to be continuous to all the portions. Of course, when you move to this portion, you first need to write all these rows first in the file, all these rows first, and then move to this one. That is the algorithm. Yeah, I thought it works properly, but apparently not. It's like when I trying to recover this first row, of the first layer, for instance, because it's not working the first layer, I ignore it or I miss this data because I take the second layer of this portion as the first layer. That is the problem. That apparently is the problem. Yeah. So I need to check when the serializer is in this row, what is happening with the data. That is the whole thing, I believe. So that would be my first attempt. Checking that moment. And that moment happens when the data is bigger than 60. Right? Bigger than 60. Let me check. No, 40. 40 rows. As you can see here, 40. 40, 40, 40, 40. And then 41. No, actually it's from 0. Yeah, I think it's from 0. So at 40, here is the first variable to take. The first value to take. So here in getting data from row, let's put here a conditional breakpoint. And let's say when this is 40, please stop. Okay, so to run this, I have this one launch configuration. And let's see. I think I have all things ready. No, I don't have it. What happened? What is this? Oh, I know. I'm rendering in the wrong way. I'm taking in with different parameters. No, but actually this has to reach this point. Let's do it more close to the main. This is the serializer function. Okay, let's check again. Has to stop here. There we go. That going in. There we go. All this thing is just to open the files. This is the point I need to reach. F. There we go. This is just for construct the structure. I mean for packing the information, sorry. This is for packing the information. Then here to take the total data rows. Here will be the point where we start getting the data rows. What is here? And then if we move here, see, it's reached this part. But why the breakpoint was not hit? To the rows. Okay, let's move to the call stack here. 40. Oh, of course. 40 is the limits. Wait. Nuke. Why? Why are we taking just 40? Has to be 80, right? Nuke? I mean, if we have in tile 40 at the beginning, of course here is 40, I mean 80. Right? Why is this just 40? Well, where is this variable? Oh, that is the problem. Nuke. That is the problem, Nuke. Of course. We are taking the rows of one map, but it has to be the row of a world. Yeah, totally miss it. Where is the world? The world's here. Yeah, I need here a function that just get me the actual rows. And I think I have some sort of state get dimension in number of tiles. This one. This one could be. I need to remember to put comments to remember. But this, I think it's this one, because if I, according to the name, this gives me yeah, the amount of this has to be the function. Probably may I ask you a child related question? Of course. Ask me. You are allowed to ask whatever you want. No, of course. Be my guest. Tell me. Okay, how to update tile sets without breaking already raw maps? Update the tile sets. I see. Yeah. Let me check this. So you mean these things, right? How not to break these things? Already draw. Let's say gaming progress. So most likely that will change quite often. Yeah. Is there a way to store many levels? I mean, the first question is how to not to break it. Well, I think it's I don't know if it's a way to keep the to keep maybe the problems could be if you change in the texture, if you change or add more columns and rows. What I mean is this: I will follow this approach if I face the same problem. I will say, okay, if you don't have ready your tile set, try to give me the template you will use for your tile set. for instance, there is a problem. It's called pixel edit. And normally, when you have a workflow in pixel edit, I mean, my workflow in pixel edit will be like having the layers there, and then coloring the layers with different colors, and say this will be my template for following the tiles, the tile set, and I will give it to you. And most likely, I will use this template. You can use that template to arrange some tiles and then render those tiles. The problem will be when you increase the size, and will most likely happen because the numbers will change. The problem is with tile that when you use more tile sets to do your maps, the numbers of the IDs will increase according to the amount of tiles you have. For instance, I have two here. Two tiles, and I will show you here, show you the test world. Oh, where is it? This world, I think it's this one. I will show you. No, it's not this one. I will show you the tester. There we go, here. I think with this one I can explain you. This is the tile set actually. One. No, it's not here. This could be this one. Yeah, it's this one. I will show you here. So basically, if size is the same and I don't mess with order of all tiles, everything should be okay. Why? Because if you increase the size, you will have more IDs because tiles with the what the tile do is to arrange all the tiles with IDs. So this will be the first one. This tile set has offset, but this will be the first one, second, third, and so on and so on, right? And move to the next row. It will be continue with from this number. We'll continue with this number, and then we'll do it anyway. Of course, if you increase the rows or the columns, those numbers are going to change. Exactly to ID. Exactly. Before having my second algorithm, the algorithm you helped me today, I have another algorithm to make use of those coordinates, which I believe is around here commented. This one. This is the first algorithm I did, and it's based on that IDs, correct? So if you change or increase the sizes, you add more tiles, that say it that way, you will increase these IDs. And of course that will mess up everything. When you load the next image here, tile will be crazy with the numbers here, and you will see a lot of red stuff. That will be the problem, because it messes up with the IDs. And of course, the next tile start, the ID start when this finish. That's why you see here this number. You don't see one, you see this one, because it's a start from the end of this and continue the numbers here, but just in the save file. Because when you see here, you will see the tile is it's not exactly that number. I can show you. Let me see if I can show you. 0, 0. Yeah, here in this part here, you will see a number here, which is 300 and something right now. But that is because it does not take into account this offset. So when you process in your engine and your render, you will need to take this value to increase the offset. Because actually this 300 and something is plus this one. So I should use bigger tile sets or just increase amount of the tile setting. Yes, increase the amount. Exactly. Yes, actually, yes, that could be another solution. If you increase the tile sets, you will also can include several more tile sets. Of course, probably. Yeah, if you manage to have a program that combine all those IDs and also then combine the textures in a single textures, or having a group of texture, you decide to combine, for instance, the first and the second, and then doing pairs, and by doing this, also combining the IDs, you can also make like your final assets in that way. Yes, that is correct. Yes, that's it. That could be another solution. The second question you have it was: is there a way to store many levels in single file? Levels in single file? Use case: I want to pre-made different rooms and then combine them via my app. Yes. Is there a way to store many levels? Yes. Yes. There are several strategies, I will say, that you can follow with these combinations of the combination of between file and render, right? I like the strategies. This is just a personal posture. I like the strategies when you combine virtual memory, which is the case of having a file. In this case, memory map. I prefer using memory map instead of just loading everything in RAM, because I just don't like it. And then using offsets, I can move where is exactly the position I want to render. So if you, for instance, like try this approach, you said, okay, in this big file, I will memory map this file, and with the offsets, I will move through the address of the file. And when I enter to this room, for instance, I know that the tile information of that room is in this address. So I move the offsets. I can show you, maybe I can explain here. This binary string is actually a memory map. So this offset, as you may know for sure, will tell me, okay, this guy is going to this room. Move the offset, or you already have the offset in a variable or in a structure. I don't know, maybe in a graph. If you want to code it in a graph, I would like to code the runes in a graph in this game, by the way. And having a node of that graph, you said, okay, this is the offset I need to move. So I move here, and I know I will render the tiles in that offset. And for that, I will have like the possibility to change room kind of quickly, because I already have the address in memory. Of course, when you read from the file, you know that this is time consuming as well. Everything that implies reading from the disk is time consuming. Okay, so the next step to address that time consuming stuff is to having a buffer in memory. This exactly version of my map renderer has this buffer, which is small because it's just a row. But maybe you can decide to say, okay, I will load more data because I will expect my game to run in this type of computer, like have at least 16 gigabits of RAM. And yeah, I think it could be possible to fit all the data at once. Of course, that will change if you said, I will port my game to Android devices. And memory map probably is not the best approach. Or maybe this buffer is too big and I need to split my strategy here because I cannot spend a lot of memory in a Android device. Or maybe yes, or maybe not. It's decisions, right? Another possibility could be combination of files. I mean, before that, I need to telling you that doing memory map is also very platform specific. I can show you actually front state. This memory mapper I have here is just for Windows. So if I want to run this game, which is my actually my intention to run this game in the Steam Desk, a Steam Desk is Linux. It's Linux, just Linux, pure Linux, right? It's just a distribution of Linux they did, and then with a graphic GPU and stuff. This code is not going to work. I know for sure. It's not going to work my memory mapper, so I need to pre-compile this thing to make for Linux platforms, to make it for Linux platform. That is platform specific memory mappers. This is a warning. This is a thing to consider. Another thing to consider is any platform also has the constraint about how big this memory map could be. I think in Linux is 2 gigabits, 2 gigabytes. I think so. Yeah, I have seen the documentation. I was looking at documentation in C Sharp, and I think they say that it's 2 gigabytes of memory mapper, because after that it could be it just some schedule of the between memory, virtual memory, and the program, and so that could be another issue. So you have to be aware how big could be your memory map, right? So that's one approach, using files, memory map, and offsets. Another approach could be have a combination of strategies. You can say, okay, I will render my maps outside any house, for instance, using memory mappers. But when I go to a town, for instance, and I want to go to a room, a house, or something, what I could do is to load that data from a different file. And yeah, I just has to be aware that loading that data could be some time consuming, and if I'm able to do this code very quickly, it's not that represent too much. Why? Because a house is normally not that big, so it will not require too many tiles, right? So if I load this data, it's not that big. I know it. This is kind of, yeah. So it will be fast loading a small piece of data from the disk and very quickly, because it's not that big anyway. I can have one single byte for that, and just telling to the reader, to the stream handler, hey, read me from this offset to this offset, and read me that, because this run is corresponding to this offset. And then yeah, loading this will be render my house in this particular example. I know what you're talking about, but I feel like we are going somewhere else. I'm making a rogue game and I need to generate procedural levels. I try to do it truly procedural, and I do it quite well for games and natural stuff. But just ruin our heart. So idea is to have a list of pre-made rooms, and I can use this template and combine it. Or alternatively, I can analyze them and strike rules to generate new types of rooms. I just thinking how to store them. Oh, I see. General procedure, procedural generator. Hmm. That is another quite nice topic. Yeah. Are you using any source of information for this? I have seen some books. Uh, I don't remember the name of the guy right now. I have read some pages of those books, and yeah, sounds interesting. That Dale Green, Dale Green could be procedural generator in C++. I think is the name. I also interested in general procedural generation. Let me check. Yeah, Dale Green is the name. Yes, 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 it's this guy. Had you checked this book, by the way? I don't know if I'm a big fan of generating algorithm. Want to play with it. Also, I'm familiar with collapse and different kind of noise. Yeah, when you say truly procedural, are you seeing? Are you? I mean, are you referring to the algorithm part, right? Not the random part, because doing a truly random generator is kind of very quite big topic. But I think you are referring to the ways the game generate the the rooms. I really like it. Yes, yes. Also like it a lot. Um, are not pre-made things. Yes, yes, yes. This is the book. But I think this guy um, didn't do without human intervention. I think he combines a bit. I am checking this book because I also want to include some general uh, some generator in this game, and I think it has also a very nice example of his. He has a small game in the book. He used a small game in the book made in C++ and using also SMFL. And the example is in GitHub, so you can compile that, and it compiles actually. I compile it, and yeah, you can play with that. And also, if you didn't check it, oh, of course, yeah. Do you also string Nuke? Oh no, no, you. Okay, I will follow because I see you are in the same page as me. uh, I will check this. What is this? Ah, these are just one of just a test. Nice. That is very nice, Nook. With each other. So I was playing with GS to generate and bodies. Nice. Looks very nice. Nook. Let me check the second one. Oh, I see. Have you also played with voids? Did you also do something? Have you done something with the voids? Do you know how other things I would like to make is ah I also forget the name. Always forget the name. This well, animation, procedural animated things, right? It's animation with procedural for algorithm and with GA. Yeah, yeah. Yes, yes. I know what you mean. Kind of nice, definitely. Yeah, very nice. And what you are using, the API you are using to render, is also OpenGL, Nook, or are you using any some different, I don't know, maybe Vulkan or something with a higher level or no? OpenGL, you are using OpenGL. Nice. So we are on the same page. Nice. I see, I see. Very nice videos, very nice projects, Nook. I like it. Yeah, yeah. I will check your videos definitely. And now I follow you as well. So if you also do some stream, I will see, will watch them. Yeah. So do you have any plans to use another API? Maybe what would be your next API to use? Vulkan probably or DirectX? My answer, actually, I don't care. Vulkan was very hype. They promised we were in every teapot, but it was a lie. In general, I think making stuff you want to make is more important than ignorance. Language technology is better. I agree. I agree. Yes. I also don't understand why people fight each other because engines, is for me is not even the case. It's like trying to not realize that you use the tool that works for you and for your purpose and to solve the problems. But yeah, people still fighting for game engines. Weird stuff. Yeah. Also, some people have tell me like, why you are doing this if you already have Unity, and well, I just want to learn, and I don't know, I like it. Just that is, yeah, yeah. But maybe it happens to you as well. Right? It's just that. I mean, but yeah. Anyway, Big Phoenix, hi man, welcome in. We are here speaking about engines and stuff that the people said is yeah, one or other, but we are having fun with C++. Well, not now, mostly yet, because we already have facing a lot of problem, but we solve it thanks to Nuke and thanks to Harry. That Harry we already left, but yeah. Welcome in to the discussion, Ming Phoenix. Hi. Yeah. Well, but Nuke, I already have some ideas how to fix the problem of the game. So thank you for the nice discussion. Look, Mick Phoenix, um, we did this today. We fixed this problem. We were facing the problem that we render more than we have, and now we are trying to solve this other problem that we don't have the layers. But I think we already have the solution for this. That snake Python 1 poisoning data for that C++. Yes, yes. I mean, Nuke is saying that the problem here in C++ is the Python is poisoning the data, and it's right. It's right. When I write the data for C++ from Python, I mess with the data. I am messing up with the data. That is the problem. That's why we don't render the foreground in this scene. But I think we can fix it very quickly. Yeah. Actually, but to try this will be. Let me try really fast. In Serializer. Sorry, in Serializer. Yeah, we will change. What was the function? I don't remember. This one, right? If this function return what I'm thinking is returning here, you can comment this. Sorry, no, it's this one. There we go. And this is this. Yeah. Ah, thank you. I definitely can fix it. And we demystify it. Yeah, thank you as well. Yes, it really sucks. World point. Okay, so let's do it like here really quick. So from tile, I will run the generation. What is the macro I have here? This one I will generate from tile. Let's see if this work. I think it's working. So now I have a different file for C++ to read. So let's check C++ now. Let's go here, here, here. No, not this one, this one. So let's check. Like very quickly. No, not even that. Fix the problem. But this is actually taking the right values. We don't need this. We don't need this. Oh, this one is the right value, at least. Yeah, it's 80. So, but I'm still writing the data in the wrong way. Oh, sorry. Yes, I need to minimize this. That's true. But this is I was saying this is the right data. It's 80. It's the right data. Right, yes. I mean, here when I eighty rows, yes. That would be 80 rows. Then going in here. Yeah. Dun, dun, dun. If we remove all these breakpoints, we will break here because this is 40. 40. And what happened with 40? Okay, this filter stakes. It's not empty. This filter is taking the right thing, right? Let's check it. Boom. This to list. So you don't like Python Nuke? I mean, you don't usually use it. I do. Okay. Okay. Now you answer my question. But look, yes, it's wrong. It's a wrong filter. No, actually, it's the correct filter because it's Y16 is 600. Yes, it's the right filter because it's giving me the third tile in the position of 0. Yes, it's working. It's this one. It's this one because this one is 0x and 640 this coordinate. So it has to be this one here. And this one, what is it? Same. Look, this is actually the last one. So the filter is working. And I'm taking here the freeze layer. I am a C++ guy, but they forced me for 2 years to write in this microservice and I know what you mean. I know what you mean. Yes. Well, I mean, Python is good for this type of things. It's like scripting very fast and get the words done, and then you can move to the interesting part, to the code that we actually do, that they actually do the heavy duty. Yes. But here I'm saying that the index layer is correct. So when I move one instruction, the binary data, the binary array is correct, right? It's empty. It's empty. Look, it's empty. Look, it's empty. It's empty, look. That is the problem. Look, it's empty. So this is invalid. Why is this empty? Yes, no valid. I mean, this function is not working correctly. That's I told you. I always return valid, of course, but okay, it has to be not valid, right? So let's inspect in tilemap this one. Tilemap. Get data row. And in layer I have data row. Layer. Get data row. So, but do you like specifically C++, Nook, and not or these languages that are let's say low level? I am not referring to low level exactly, but they compile to a machine code. So what I want to ask you, what do you think about Rust? What do you think about Rust? See, it's always returning true. Of course, that is bad coding, but yeah. Rust is okay, but I don't like fanboys. Exactly. Exactly, my dad. Exactly. Yeah, I think Rust is okay. I was playing with it some month ago, and it's kind of nice. Has this cargo stuff. I like it. Yeah, it's kind of get come with features, and those features I like. Yes, but yeah, it's the same as we were talking about. Look, go into a thing and then it works for you, you become a fanboy and say, yeah, this is the best. You must try it. You are doing the wrong way because in Rust and Unity could be done here. Yeah, it's the same. So here, this one. Let's inspect this. What kind of this crazy purpose? Watch it out yourself. You didn't. You're yeah. Yeah, because once I was in I was reading through internet stuff and stuff like yeah, making games, and I came across with a post in Reddit, a guy saying yeah, I'm changing to Rust because C++ is kind of updated right now and nobody's using. And I mean, I work with C++ every day. My job, at my job in C++, and people saying that it's outdated and not even use it anymore. I was like, what? What this guy is talking about? Generally, was I mean, I just laugh honestly. Roles and function languages are overprotected. In the end, language like C, Java, Python don't really give understanding of memory, caching, performance. Exactly. Yes. Yes. True that. Yeah, but they are still useful for some purposes, and that is okay. Just saying that this is the solution, and what you are using is outdated. That is wild. I mean, saying things like that is wild. Yeah. This is weird. I mean, according to the boundaries of the array, it's actually have data. I mean, this array have data, but could be nuke that because all that data is zero. No, it's not possible because that data is not zero. I mean, those binary are from ground and those are different than zero. No, 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 no. So why is this thing giving me no bytes? And the boundaries are good, they're correct. What? Well, maybe I'm too tired now because I can see it. Damn it. Wow. I don't see it. I don't see it. Definitely not. Well, maybe I'm too tired. I'm getting sleepy. So it was a long week, Nook. Thank you very much to helping me. I think I will stop it for today. I will go back tomorrow to this naked data thing. But yeah, I will. It was very nice to having you here, Nook. Thank you very much for your help. I don't know if you allow me to rate you to another C++ guy as well. Let's see if we can find a C++ guy. Same or similar size, same category. Where is a block game developer? Go. Oh, this is Go. No more waiting for Godot. War is kind of hard to find a C++ guy doing C++. Unreal. Well, Unreal is kind of C++. That is why I yes. Oh, dude, definitely it's hard. Nobody likes C++. Come on. Oh, exploring CDL3 in C. That could be maybe. This guy. Yeah, let's go to see this guy a bit. Yep. Okay, is coming, I believe. What is the so weird? Let's do it again. What happened? I think this guy stopped streaming at the right moment. Where is it? SDL, where are you, SDL guy? Ah, we are unable to raid lightning at this time. I don't know why. Well, anyway, if you are going to sleep, so never mind. No, thank you very much. Have a good rest, man. Thank you again. And I hopefully we can meet together again. Thank you, man. See you. Bye bye.